Hello, in this session I'm going to continue with looking at past exam questions on algebra. Let's start with this example. Find the value of a when 3 to the power of a divided by 3 to the power of 4 is equal to 3 squared. Right, in this case, there are different ways to think about this. If we have two numbers to the power of something and divided by each other, we can find the answer by taking the difference between the powers. So just to think of an example to get into this question. For example, if I have say 3 to the power of 7 divided by 3 to the power of 4, the answer would be 3 to the power of 7 minus 4. So this is the method that we can use to do this question. And the reason why this happens is because 3 to the power of 7 is really 3 multiplied by itself seven times or 6 times, right? 7 factors of 3. Divide by 3 to the power of 4 means 3 times 3 times 3 times 3. So we have lots of factors of 3, and the way to find the answer quickly is to simply do the cancelling, divide the top and bottom by 3. So that's those cancel out, then divide by 3 and 3 again, 3 and 3 again, and 3 and 3 again. And then we'll find that we have only 3 of the 3 left. And a quick way to do this is to simply take the number of 3's on top, which is 7, minus the number of 3's at the bottom, which is 4. And that's how the 7 minus 4 come about. So with this example, we can now see how to do this question, because all we need is to notice that the power of a minus the power of 4 there should be equal to the power of 2. Just the same as I took 7 minus 4 here to get the power in the answer. So let's write down that a minus 4 is equal to 2. So we have for part a minus 4 is equal to 2. So that's what we get from our understanding of powers. Now once we have that, it's a lot easier. We have an equation with a as the unknown. So this is an algebra equation, and we can solve it. We can solve for a now. The first step, we want to get rid of the minus 4 on the left side, so that only a is left. And I can do that by adding 4 the both sides, then minus 4 plus 4 is 0. I'm left with a on one side, and I have 2 plus 4, which is 6 on the other side. And that gives me the answer now. A is equal to 6. That is the answer to this question. Moving on, part B. In part B, we are given this. 8 to the power of b is equal to 2, and we must find b. Now, in this question, we make use of two things we need to make use of. First, we need to make use of the idea that if I have just the 2 on its own, it's really the same as 2 to the power of 1. Now we need that because, like in the previous question, we have to do it by comparing the powers, and then hopefully we can write down an equation for the powers. So the power of 2 to the power of nothing is the same as the power of 2 to the power of 1. Let me say that again. 2 to the power of nothing is the same as 2 to the power of 1. That means there's only one factor of 2. So that's that. So now I know that 8b equals to 2 is equal to 2 to the power of 1. Right. Now in the next step, I cannot say that b is equal to 1 yet, because I have an 8 there and a 2 there. They're not the same. In order to compare powers directly, I need to have the same numbers at the base, at the bottom on both sides. So I must have 2 to the power of a power before I can compare it with the right side. So in the next step, I must write 8 as 2 to the power of some number. And we know what that is. We know that 2 times 2 times 2 is equal to 8. Right? So, and 2 times 2 times 2 is really the same as 2 cubed. So 8 is 2 cubed. Now, next I have to think about the b. Now let's be very careful at this step. I can just replace the 8 by 2 to the power of 3 and then just put the b next to it. Now, but we have to be careful with such things in algebra, because you know that if you put two things together, we are supposed to multiply them. Okay, if you put two symbols together with no signs in between, it means that that you're multiplying them together. But in this case, we are not really multiplying the b by the 8. b is really the power of 8. So things are a little more tricky at this stage. And the safest way is to do it step by step, which is that when I change 8 into this form, into 2 to the power of 3, I've just changed the 8. I've not touched anything else. And the safest way to write down the results is to put a bracket around that. So everything that I've done to the 8, I put it inside the bracket. Okay, and I write that bracket in place of the 8. So whatever I do to the 8, I draw a big bracket around that space and I put everything inside. So in that case it's safe. I can be sure that I've not made a mistake. And also, it also means with a bracket that whatever you do inside the bracket, you must do first before you do other things, like raising it to the power of b. So this is what it should look like in the next step. We have 2 to the power of 3, and the 2 to the power of 3 as a whole is then raised to the power of b. Now I have 2 on both sides, and I should be able now to compare the powers directly, except that it is not so clear what the power is at the moment. Is it 3 or b or what? Because after all, I have a bracket there. And in order to simplify this, in order to carry on, I must remove the bracket. And to see what we should do, let's look at an example. If I have, for example, 2 to the power say 2 bracket, and then this whole thing to the power of 5. So let's look at that as an example. Okay, we have just numbers and no symbols. If I have 2 to the power of 2 and then bracket to the power of 5, actually let me make it simpler. If I have, say, 2 to the power of 3 and then the whole thing bracket to the power of, say, 2, what this means is that it is the square of 2 to the power of 3, so it can be 2 to the power of 3 times 2 to the power of 3. Right? And we can think that this is 2 to the power of 3 plus 3. Okay, and 2 to the power of 3 plus 3 is really the same as 2 to the power of 3 times 2, because there are 2 of the 3's there, and the 2 of the 3's comes from the square down here. So this means that we can have a simple way to find the answer for this expression. I can go straight from there to the answer by taking 3 times 2 to get the final power. So with this understanding, I can now go to here and say that 2 to the power of 3 bracket and then to the power of b should be the same as 2 to the power of 3 times b. Right? Which is the same as 2 to the power of 3b. 3 times b is the same as 3b. Now we can compare the powers. 2 to the power of 3b on the left to the 2 to the power of 1 on the right. Therefore, 3b must be equal to 1. finally, we can solve for b. To get rid of the 3, since this is 3 times b, we can get rid of the b, of the 3 if we divide by 3 on both sides. Then the 3 and the 3 cancels. We are left with b on the left, and we find on the right that the answer is 1/3. So that is the solution to this question. In the next example, we shall factorize 4x squared minus 1. In order to do this, it is easier to make use of a formula. This is a standard formula, and to understand this, we can expand the right hand side, by removing the brackets one at a time, and check that when we simplify, we will get the left hand side. So I've explained that in an earlier session. I shall not go through that now. And what I'll do here is to assume that you already know this formula. It is something that you should remember for exams and for questions like this. And I shall make use of this to answer this question. So the first thing to do is to compare this formula. Compare the a squared minus b squared with this. And to see and to look for the terms that are similar. Well, the obviously similar thing is the minus sign there and the minus sign there. Okay. And then the next thing is that there are two terms here and two terms there. And then we want to compare the a squared to the 4x squared. Now both of them have a square, but this has an extra factor of 4. So the idea is to then see if we can rewrite the 4x squared in a form that looks like a squared. Now a can be anything, can be any number or any expression. So we want to see if we can rewrite the 4x squared into something squared. Doesn't matter what that thing is, as long as it's the same as 4x squared in the end. And the way to do that, let's start, is to say that 4x squared is to notice that 4 is the same as 2 squared. We can make use of that. And that this is the same, really, as 2x times 2x. Right? You can separate that into the two factors. And the reason why I want to separate it into these two factors is because those two factors are the same. This is 2x, that's 2x. And the reason why I want two factors that are the same is because then I can write that as the whole of 2x squared. Alright, so notice that I emphasize the idea that I have to square the whole of the 2x and not just x itself. And to make sure of that, I put brackets around the 2x. Right, meaning that I should do the 2 times x first before I square it. And that would then be the same as 2x times 2x. Now once I reach here, you'll see that if I compare that with a squared, they will be the same as long as I take a to be 2x. So this takes a bit of foresight, and it helps if you can roughly see where you're going. You can roughly think of rearranging these terms in your mind and have a rough idea that if you do this, you'll get to the answer. And that in order to be able to do that, it helps if you practice more of such exercise. Alright. So we have that. Okay, so that's that. Now, so we now know we now know that 4x squared can be written in a form which looks like a squared. Now let's look at the 1 there. Can the 1 be b squared? Can it be written as something squared? Alright, so again, b can be any number or expression. Well, we can, because 1 is really the same as 1 times 1, which is 1 squared. So once again, this is something that you would know from practice and from looking at such examples. So therefore, 1 can be b squared as long as b is taken as 1. So once we have this, we are now ready to go. We are ready to make use of that formula. And let's do that. So 4x squared minus 1. Now we make use of what we have observed, that 2x whole squared is 4x squared, and 1 is the same as 1 squared. So with this form, now we can make use of the formula if we say that 2x is a. So I'm going to take the a there as 2x and b is the 1. And then the rest is straightforward. All I need then is to substitute the a and the b, the 2x and the 1, into the right hand side. And I have 2a plus 2x plus 1 for that, and then 2x minus 1. So that then is the answer, is the factorization. Right, when you reach here, you have factorized 4x squared minus 1. In this next part of the question, B, we are given that P is equal to 2Q plus R over R. Part 1, find P when R is equal to Q. We can do that by substituting Q into the R. Since R is the same as Q, I can replace both the R by Q's. So we get 2P is equal to 2Q plus, so R becomes Q divided by R becomes Q. We can now simplify this. We have 2Q plus Q. So it's 2Q plus 1Q, that gives 3Q's divided by Q. And 3 times Q divided by Q. We can divide the top and bottom by Q, so they cancel. Divides to 1, and I have 3 times 1 divided by 1, which is 3. And that is the answer to this part. 3. P is equal to 3. Part 2. Rearrange the formula to make R the subject. Formula is this. Let me write that down. To make R the subject, there are different ways of doing this, and the way that I prefer is that if there is a fraction, I should get rid of the fraction, because fractions are always more complicated to work with. And to get rid of the fraction, the way to do it is to get rid of the denominator. And to get rid of the denominator, we should multiply both sides by the denominator. Now since the denominator here is R, I should multiply both sides by R. Now I have RP on the left, and on the right the R and the R cancels, and I'm left with 2Q plus R. Alright, you must be careful not to just cross out the R there and the R there, because the R there is added to the Q. Okay, so that means that it is as if these two has a bracket around them. You have to do the addition first before you divide by the R. We can only cross things out if, for example, one of them or two of them are multiplied by the other terms. Like the R there, it is multiplied by the whole of the numerator. So we have this now. And let's just look at the question again to make sure that we know what we need to do. That's very useful whenever we have a question that involves more than 2 steps. Now we need to rearrange the formula to make R the subject. Looking at this equation now, we find R there and there. To make R the subject, we really want R to have just R on one side, and the rest on the other side. So the thing to try would be to move all the terms containing r to the same side. Let me try getting rid of the r on the right side. Subtract r from both sides. Have r p minus r is equal to 2q. To make r the subject, we must have only r on one side of the equation and no r on the other side. In this case, we can start by factorizing the r. We have r there and r there, and we can bring them out of a bracket. Meaning, if I put a bracket around here, and I imagine taking the r's outside of the bracket, rp would be left with p as a minus sign there. Now the r there, I can't just take the r out and leave nothing. The idea is that when I multiply r by that thing, if I remove the bracket and reverse the step, then whatever I have here when I multiply r by that must give me r. And this means that I should have a 1 there, because r times 1 is r and r times p is rp. So that's how I can take r out of the bracket. That means I've just factorized it. And on the right side, I still have the 2q. Now the purpose of doing this is that once I have r outside the bracket, I can think of this as r times a number. Alright, we can think of the whole bracket as just a number. And if I have r times the number on one side, I can get rid of the number if I divide both sides by that number. So this means that I should divide both sides by p minus 1. Alright, I should divide this by p minus 1, p minus 1. Now we have to be very careful when we start dividing or multiplying by an expression. Alright, and to be careful, we put a bracket around that expression. Otherwise, it might look like we are just dividing by one of the terms in the expression. Right, so on the left side, when we divide by the bracket of p minus 1, remembering that this bracket and that bracket are just numbers, then because these are the same numbers, I can cancel them. Alright, divide top and bottom by that same number. So if I cancel them, I'll just get 1 and 1. And this gives me r times 1 divided by 1, which is just r. Write it over there. So I have just r on the left side now, and on the right side I have 2q over p minus 1. And that's the answer. I have r as the subject now, because on the left side I only have r, and on the right side there is no r. Let's look at this question. A shopkeeper sells cartons of milk and bottles of water. Each carton of milk costs $2.40 and each bottle of water costs 80 cents. One day he sells X cartons of milk. On the same day he sells 20 more bottles of water than cartons of milk. So this is the background. And the first part of the question, write down an expression in terms of X for the number of dollars he receives from the sale of these cartons and bottles. Simplify your answer. So we start with the cartons of milk. He sells X cartons of milk. Let's find out how many dollars he receives for the cartons. Now, each carton costs $2.40. So if he sells X cartons, it should be X times 2.4. He sells 20 more bottles of water than cartons of milk. So that means that he sells X plus 20 bottles of water. So that's milk water, X plus 20 bottles of water, and each bottle of water costs $0.8. So the total is 0.8 times X plus 20. Now notice that I put a bracket around the X plus 20 to make sure that I add them before I multiply by the cost. Now let's look at the question again. We need to write down an expression in terms of X for the number of dollars he receives from the sale of these cartons and bottles. That means the sale of everything. And therefore, we should add them. And then we should simplify the answer. Alright, so this is 2.4x plus, let's remove the bracket. And we should remove the bracket because the bracket contains an x, and then after that we can hopefully add it to this term that also has an x. And then hopefully it will become simpler. So lots of hopes. Let's try that. 0.8 times x plus and 20 times x. Now quick way to multiply that. There's one decimal place here and there's a 0 there. The 0 there means that 20 is the same as 2 times 10. Alright, so the 10 multiplied by 0.8 moves the 0, the decimal, by one place. So the quick way to do it is to cross out the 0 and move the decimal point by one place, so that 0.8 becomes 8, becomes 10 times. Or the other way to think about it is that I take this factor of 10 and I multiply by the 0.8. So in any case, alright, you can do it mentally or you can write it down. We end up with just 2 times 8, which is 16. Okay, so that's a quick way to get to the next step. Finally, to simplify this, we look for like terms. So these are 2.4x and 0.8x. And we can add them up. 2.4 plus 0.8 is 3.2. X plus 16. And that is the answer. The next part of the question, the total amounts he receives that day from the sale of these cartons and bottles is greater than $250. Form an inequality in X and solve it. So this is the total amount that he receives. $3.2x plus 16, and we are given that this is greater than $250, meaning that this is greater than $250. So we put a greater than sign in between. And that's our inequality. Next, we must solve the inequality. The idea of solving an inequality is like solving an equation, we really need to rearrange this until we have x on one side and all the numbers on the other side, and then we can calculate the answer. So the rules for solving an inequality, as I explained in earlier sessions, is the same as the rules for solving an equation, except that we have to be careful when there are minus signs and when we have to divide by when we have to divide by things involving minus signs. So let's start with that. Now, to solve for this, we want to rearrange this so that we have just x on one side. We can get rid of the 16 by subtracting 16 from both sides. That gives 3.2x. 16 minus 16 is 0. It's more than 250 minus 16, which is 2. Now I'll put that 50 into, say, 30 plus 20. So the 30 gives me a 3 in the tens place, and the 20 minus 16 gives me a 4. 234 is the answer to that. Next, in order to have just x on one side, I would want to get rid of the 3.2. Since 3.2 is multiplied by the x, I would divide by 3.2 on both sides. Alright, so that's fine. I'm dividing by positive numbers. I don't have to worry about switching the sign inequality around. So 3.2 divided by 3.2, cancel, gives 1. And I have just x on one side now. Is greater than 234 over 3.2. Right. Let me take out my calculator and find the answer. Right, 234 divided by 3.2 73.125. So that's the answer. We have solved the inequality. Alright, that's the answer. Last part of this question. Write down the least number of cartons of milk he sells that day. Right, now if we remember from the earlier question, X is really the number of cartons of milk. Alright, so that's the number of cartons of milk, and this inequality, this answer to part 2, tells us that the number of cartons of milk must be more than 73.125. So that means that X, for example, can be just any number that is more than 73.125, and we also know that X must be a whole number because it's a number for counting the cartons. So X can't be 73 because that's smaller than that. So X can be 74, 75, 76, and so on. So it can be any of these numbers. And the least number, therefore, is 74. And that is the answer. 74 is the least number of cartons of milk he sells that day. Right, we'll stop here for this session. See you next time.